Hi everyone. We are presenting a topic on the solar power usage monitoring system using sensor data. Yeah, next topic. Yeah, so here are project client details. So Bob Eden is a client and he is from the website on, and our project supervisor is Professor Savitri Bebinokappa. So here are the project objectives, project overview we are going through. So optimizing solar power usage in the context of the independent living, harnessing the potential of renewable energy sources, enhancing the sustainability and cost effectiveness of the energy consumption. Yeah, next slide, please. Yeah, so here are the client requirements that we have got. Client one automatically collect, structure, and store and analyze the data. Applications should generate the reports and dashboard for the administrators. So here we have a project design. This is the overall project design. So in the project design, we have a user who will directly communicate with the front end part. Front end part, they will have the user interface with the data that have been generated by the sensor and the solar panels, and the data from the meteorological data are manipulated on the back end, and back end provide the data to the front end, which is directly interacted by the users. So on the next slide, please. So basically, this is my approach. So in the design, there are five design components, mainly the client interface, server, meteorological data integration, hardware data, and administration tools. So client interface is where user interact with the system. It provides the real-time feedback on energy generations and appliances uses remediations. Server is the backbone of our system built using the C# and ASP.NET Core MVC that helps to manage the data processing, user authentication, and communication with other components. Meteorological data integration with source data from the Australian government's meteorological API, collecting information such as temperature, wind speed, cloud cover, and rain forecast. These parameters form the foundation of our energy prediction model. So the hardware data are gathered from the sensor installed on our users' solar panels, including direct sun exposure and the panel temperature. This data is crucial for the accurately assessing the energy generation potential. And basically, the administration tools are the component facilitators system configurations and user preference, enabling them to define their energy usage priorities and schedules. So, being more technical in these approaches, like we have microservices architectures. So, ensuring the scalability and maintainability is microservices focus on the specific functionalities such as a data collection, prediction, or user management. So, we'll be using the RESTful APIs like using the RESTful principles, enabling seamless communication between the components. They will be the well documented and version to ensure compatibility as the system evolves. So we'll ensure the security measures. We'll implement robust authentication and authorization mechanisms, encrypt sensitive data, and regularly conduct security audit to safeguard users' information and system integrity. So on the last side, like automation is our heart of our system, lies in the automations. User provides their preference and the system takes over, dynamically controlling appliances to maximize solar energy utilization based on the real-time condition. Uh, so next slide, please. So this is the initial implementation like we have gone through. This is the Visual Studio where we started doing in the C#. This is basically how we will start the coding part. Yeah, next slide, please. Yeah, from here the Susan will start.
My design approach is using the cloud for the storage and monitoring system. In this approach, we use the router in the both end to route the data to the cloud from sensor and also the data from the cloud to the end user. For the cloud service, Amazon Web Service is used. The service include Amazon S3 for data storage, Amazon Cognito for user management, data lakes and analytics for data analysis, Amazon and data sinks and database. The flowchart explains the flow of data when it arrives from the cloud from sensor. We can see when the data arrives, it is saved on database, which is further forwarded for data analysis. Then the result is saved into the user profile. In terms of implementation, I have created instance and bucket in AWS. Instance stands for virtual machine on the cloud, which act as a server for receiving data and user management. Initially, limited resources is provided. In the next step, bucket is created, which is required to upload and save all the data in the AWS servers. For the slide will be explained by my friend Bipin.
Okay, I'm going to describe about the efficient energy management. For this, we provide the flowchart about the algorithm, optimize appliances used by considering electricity prices and storage. It communicates with smart meters to check if the power is available or not during the peak hours when the clients are needed. If available, appliances are restarts. It verifies local energy and appliances power. If the energy is not available, appliances cannot be used or it shifts usage to off-peak times. We use the fuzzy logic controller, which is used in the system algorithm, and this fuzzy logic controller decides when appliances run, and user can choose to follow the schedule according to the power available on the system. Next slide, please. And this is the initial implementation for the algorithm. We use the Visual Studio Code, which is provided by the Microsoft. We can easily download it from the official website of the Microsoft. And in the Visual Studio, we provide the initial code for the algorithm, and we will implement all the development strategy on this tool. For calculating all the energy efficient, we need to calculate available energy on the system according to the available sensors data and everything. Thank you.
I am going to design approach of using IoT sensor. In my approach, solar panels are connected to the different sensor motors such as temperature, solar voltage, current sensor, and other. This data are transferred to the Raspberry Pi for the processing, which convert data into web accessible format. The data is sent to IoT device such as manageable switch. For this, it transferred to the cloud for the secure storage and analyzed through a firewall by secure layer, that is VPN, virtual private network. The cloud-based system provides data on the demand and user activities. Next slide. This is the implementation page on the packet tracer. The next topic is described by the Gaurav.
Yeah, so hi guys. So data security plays a paramount important in development of any system. So I'm focusing on the data security part of the software development. So while developing the software for our solar system, I'm using a penetration testing model. That's a 5-stage penetration testing model, which includes a portal access. Then we will be doing scoping and discovery, and then vulnerability assessment. Then we'll be exploiting the code internally, so that if something is found, like a bug is found or something like that, and then we'll be documenting it in the report. And if there are some issues found, we'll go back to the remediation process, and then again the process will start. So for this, the penetration testing software, what we are using is Kali Linux, and vulnerability assessment tool will be using Burp Suite, and Armitage as an exploitation tool. Next slide, please. So this is a screenshot of Kali software, which we have downloaded in our PCs, and we'll be working on that. Next slide, please. Yeah, and this is the Burp Suite. So this is like the exploitation of the code by using the sniper attack. And then we are also doing exploitation by using Armitage. So this is the initial implementation. And coming on to limitation of the project, see, solar system is the conventional form of energy. So weather plays a very important effect on the data consistency. So sometimes there is sunlight, sometimes there is not. So that has effect on will have an effect on our projects. Next slide, please. Yeah. So conclusion is like, yeah, people who will use to like guide their choices about how much energy they use can save money and help. And it will also help in the environmental impact, as we are using the conventional form of energy. So it will have like more benefits, and we can control the climate change. So yeah, thank you so much and these are the references. Yeah.